Hello everyone. The biased hypothesis is biased towards only the few example. It is unable to identify all the examples target concept to make that given hypothesis is consistent. So to solve that biased hypothesis issue, we have to use unbiased hypothesis, which will be created by using the power set of given data set D. So we will create the unbiased hypothesis by using the power set of D with respect to the weather data set, which is having 6 attributes. The learning system is learning the knowledge using power set of all given training examples given in the instance space X. So there is the possibility to get solution to all different type of examples with different feature values. So here sky is having 3 types of values, and temperature is having 2 values. Like that, all different type of values are having with different attributes. So based upon this, there is the possibility of creating 96 number of training samples with 6 attributes and different values. The target concepts are possible to produce the power set of hypothesis 2 power cardinality of x, here 2 power 96. So it will create a huge hypothesis space. Okay, so the hypothesis space is there. It will have h1 etc, h h2 power 96th value. So okay, so it will have so this many hypotheses available in the hypothesis space. But whenever you are feeding the training example x1 x2 etc, x1 10,000. Okay, so for each and every training example, this has to be checked with all 2 power 96 number of hypotheses. So it will take more time uh, to find out the target concept. But whenever you are designing the learning system, it should consume only less amount of time. So here the unbiased example is given. The learning system is learning the task in unbiased approach by defining the new hypothesis space h dash. So here the h dash is the hypothesis space, which is subset of given instances in the data set. And to define the h dash, we can use arbitrary disjunction of positive example and negation of disjunction of negative examples. For negative example, we will use the negation, but for positive example only we will use the disjunction. So using this, we will create the hypothesis space h dash, so which is subset of hypothesis space capital H. For example, the target concept may have sky value, may have a sunny, or disjunction. This is the disjunction value. Sky value may be cloudy. So how can we describe the hypothesis here? So we are describing the hypothesis 1 here with sky value is sunny, and remaining all constraints are general constraints, and or this is the disjunction. So disjunction of another hypothesis. In this hypothesis, we are having the sky value is cloudy, remaining all are general constraints. So here we are using two different values. That sample may have attribute value cloudy or sunny. So this hypothesis will identify the result for two different values of sky attribute. So this is unbiased towards the examples. Here another one example is given. Suppose we will have the 5 examples in the instance space x. 3 are provide you the positive target concept, which are x1 x2 x3 samples, and 2 samples which are giving negative target concepts x4 and x5 samples. Then you consider specific boundaries of version space is having the hypothesis disjunction of positive samples. So here 3 positive samples are there. So sample number 1 disjunction of sample number 2, disjunction of sample number 3. So these three samples are available in the specific hypothesis. Yes, okay. With respect to three hypotheses, okay. So now the general boundary is having version space which is having the consistent hypothesis with negation of disjunction of negative samples. So here we are having the two negative samples x4 disjunction of x5. So negation of this sample, so negation of these samples. So from this what we are observing, it is very sensitive hypothesis which the system is provide you very sensitive hypothesis with respect to the training samples. That is, specific boundary is always having disjunction of the positive observed samples. So the specific boundary is always related to the disjunction of positive samples. At the same time, general boundary is related to only the negation of negative samples, disjunction of negative samples. But the learner uh, completely unable to generalize beyond the observed training examples. So it is unable to classify beyond this type of examples. That is, it may or may not correctly predict the newly coming testing samples, unobserved samples. So there is a possibility of misclassification for the new testing samples. So what we have to do, we have to check with all the training uh, examples in this approach. So here which is taking again more time to check with all the samples to make the learning system into perfect process, even though there is the possibility of less amount of misclassification possible. Thanks for watching.